so my question is if dicarbon tetrahydride was fully combusted in the presence of oxygen to produce carbon dioxide and water. So we'll start with the skeleton equation. Dicarbon tetrahydride, di means two, so which means there's two carbons, and then four hydrides, or hydrogens. And then combustion in the presence of oxygen. Oxygen, the diatomic atom, or element, so it comes in pairs of two. And then a fully combusted anything combusts into carbon dioxide and then water. So this is our skeleton equation. And in order to balance it, we have to write on the side what is on the left side and what is on the right side. So there's carbon, hydrogen, and oxygen. There's two carbons on the left and then one on the right. There's four hydrogens on the left and only two hydrogens. There's two oxygens on the left and then three oxygens on the right. In order to balance, we have to make sure all of these are equal. So to start, we'll put a 2 in front of the carbon dioxides in order to make the carbon dioxides equal. And that'll change how many oxygens are on the right side. It'll change from 3 to 5. So now we'll worry about the hydrogens. There's 4 on the left and then 2 on the right. So we'll put 2 here in order to create 4 hydrogens and then 6 oxygens. And in order to fix the oxygens, we just have to put a 3 on the left side, and that will change and make it all pretty and balanced. Now to start with the second part of the problem, which asks if 153 grams of carbon dioxide were to be produced, how many grams of oxygen would have reacted? So what we're going to start with is what it gives us in the problem, which is 153 grams of CO2. And then what we want to be in at our last bit of the equation is grams of oxygen. Alrighty, so the first thing we have to do is put the carbon dioxide into moles, because that's how everything is and switched around. And this is going to be called our molar mass ratio, which is found in your periodic table. So on top will be 1 mole of CO2, and then on the bottom will be grams of CO2, so the grams cancel out. Okay, so if you look, alrighty, so now that there's 1 carbon weighs 12.01, and there is 2 oxygens, and oxygen weighs 16.00 grams. So now we'll add these 2 masses together. So 12.01 plus 2 times 16 gives you 44.01 grams of CO2. And that's what we'll put in the lower half of our math here. Alrighty, so now that the grams cancel out, we'll continue on and we'll go into moles. This part of the equation will come from our balanced equation, which means it'll be a mole ratio. So for every 2 moles of carbon dioxide there is 3 moles of oxygen. Once again, we get this from our balanced equation. You can't get it from your unbalanced equation because then it'll throw off your numbers. And this is the mole ratio. Next we have to, so now that we cancel out just moles of CO2, we have to cancel out the moles of oxygen because we still need to be in grams. So for every 1 mole of oxygen, there is 32 grams of oxygen. The reason it's not 16 like it was And like it says in your periodic table, is because once again, oxygen is a diatomic atom and it comes in pairs. And then this is once again a molar ratio. So now that moles have been crossed out, moles equal 2, now we're in the grams of a 2, which is what we need in order to answer our question. So now in your calculators, you write 153 times 1 times 3 times 32, and then you'll divide all of that by 44.01 times 2 times 1. And that'll give you 166.871. Now we have to count how many sig figs we have to know what number of sig figs our answer will be in. So this number here has 3 sig figs. This number here has 4. And this one here as well has 4. The single digit numbers are just counting numbers, so they won't affect your amount of sig figs. The rule for multiplication is that the lowest number of sig figs goes into your answer. So our lowest number is 3. So our answer will be rounded to 167 grams of O2.